Hey guys, it's Landon Blake with taught-by-a-surveyor.org. This is another video we're just doing on some basic math, right? So we're going to talk in this video about ratios and proportions. I actually had to go do a little bit of homework for this video because it's been a long time since I knew the exact the technical terminology for some of this stuff. So I did a little homework, I did a little reading, and I think I'm ready to teach you guys about ratios and proportions. The reason I decided to teach this video topic is because we're dealing with similar triangles in one of our other videos, and we're getting ready to talk about the trig functions, and trig functions basically work with ratios. And I thought, you know what? We need a video that just explains ratios and proportions from a land surveyor perspective. So we're going to answer these three questions. What is a ratio? What is a proportion? I'm missing a question mark there. Sorry. That's why this isn't taught by surveyor English and grammar. What is a proportion, and how do we solve proportions? And then we'll use some examples, a couple funny examples, and then we'll use kind of a real life example from surveying. Okay, so what is a ratio? A ratio is a way to express a relationship between two parts of a whole, or a part the relationship of a part to a whole. Now that sounds super confusing. So what does that even mean? It'll make sense with an example. So I don't know if you guys have noticed this, but I love iced tea. I drink iced tea all the time, way too much, probably more than is good for me. So let's say that we were going to make some sweet iced tea. Now I don't drink sweet iced tea because I already have a belly and I'm trying not to gain weight. But let's just, and I love sweet iced tea, so let's pretend I'm gonna let myself have a special treat. Tomorrow's Sunday. I'm gonna make myself some sweet iced tea. Okay, so we want to know how much sugar to put in our iced tea. Now let's just say we go to Google and we get a recipe for iced tea, and it says for every gallon of water, so we could just write this out as a sentence. For every gallon of water in your sweet tea, you need 1 cup of sugar. Okay, now I don't know if that's an accurate ratio of water to sugar in iced tea, sweet tea, so don't take my word for it. Go Google it if you want to know for sure. But we could write that out as a sentence. Okay, but remember we talked before about, we don't write most math out. We use symbols to make math easier. Okay, so the way we would express this as a ratio, there's a couple ways you could do it. We could say, you know what? I'm going to change this a little bit. I'm going to say for every gallon of water, we need 2 cups of sugar, just to make the math work a little better. Okay, 2 cups. Okay, so the way we would write that as a ratio, there's 2 ways we could do it. So we could say 1 gallon of water, say 1 gallon to 2 cups. Okay, now this is the unit, right? That's the unit we're talking about. Okay, we're going to get rid of the units just to make it easier. So our ratio here is 1 to 2, and we just use a colon for that. Okay, the other way to write it is as a fraction. So you could write it like this: 1 gallon of water to 2 cups of sugar. Okay, now it doesn't really matter which direction you write the fraction. You could say 2 cups of sugar to 1 gallon of water, as long as you remember which number's on top, right? All we're doing is expressing the relationship. We know we need twice as many cups of sugar as we have gallons of water. Okay, that's how we're expressing the relationship between the amount of water and the amount of sugar. Okay. Now, just as an aside, if you change either one of these units, you change the ratio. So the units are important, and they're important in surveying. So for example, if we started talking about quarts instead of gallon, now we need 4 quarts to 2 cups. Okay, but you'll see when you get rid of the units and simplify, you end up with the same ratio. Okay, but just remember, units are important. All right, so let's look at another ratio. Okay, and then we're going to see how we can use proportions to solve problems with ratios. Okay, so I don't know if you guys have noticed this because I wear a ball cap most of the time, but I have lost most of my hair. I also have forehead wrinkles. So let's just say that in America, okay, we're going to write this out. So let's just say the United States, in the U.S., there are 3 bald men for every 5 men with hair. All right. I don't know if that's a true ratio. Be interesting to know what the ratio of bald men to men with hair is. Okay. I know bald men are much more handsome than men with hair. 5 men with hair. Okay. That's a true fact. I don't know if you've ever heard that before, but okay. So how would we express this as a ratio? All right. So we've got 3 bald men to 5 men with hair. Let's call it MWH, men with hair. Okay, that's our ratio. Okay, so if we drop the units, we've got a ratio of 3 to 5. Okay, or we could write it this way, 3 over 5 as a fraction. Okay, so that's another example of a ratio. Now, what is a proportion? A proportion is 2 ratios that are equal to each other. Okay, so let's go back to our sweet tea example. So you remember we said for every gallon of water, we have 2 cups of sugar. That's our ratio. So now we want to know if we have 5 gallons of water, okay, that means we're going to have 10 cups of sugar. Okay, 1 to 2, 5 to 10, those are equal. This is called a proportion. Okay, so a proportion is 2 ratios that are equal. Now you may think, whoop-de-doo, what's so special about that? What's important? All right, well, we can use proportions to solve problems. Okay, so let's just go back to our example of the bald men. So remember I told you there's 3 bald men in the United States for every 5 men that still have their hair. Let's say men over the age of 25. Okay, now, we go to a surveying conference. Okay, and we're in a class at the surveying conference, and we know that in that class there are 123 men over the age of 25. Okay, that's pretty typical for your average surveying conference. There's probably 123 men over the age of 45 if it's a surveying conference. And we want to know, all right, based on this ratio, how many of those guys can we expect to be bald? Right? How many are like Landon? They're wearing their bald cap. They're wearing their ball cap because they don't want everybody to know they lost their hair. All right, so we can use a proportion to answer that question. So let's just look. Okay, so let's write this as a proportion. We have 3 over 5, that's our first ratio, equals, now, we don't have the number that goes on top here. What we have is the total. We have 123. Okay, we know there's 123 men in the class, and what we're trying to solve for is the missing number over here. Now, you know from our videos on algebra, we like to write that as x. Okay, so how do we solve this? Okay, well, the way we do it is we use what's called cross multiplication. Okay, now I'm going to rewrite this a little differently so that it's a little easier to do cross multiplication. Okay, so we've got 3 over 5, that's our first ratio. Okay, and then we know we have some number x over 123. Now, we want to solve for x. We want to know how many bald guys are there in the class at the surveying conference. Okay, so here's how you do it. You cross multiply. Now remember, when you cross multiply, let me get a different color here. When you cross multiply, you go diagonal, right? So we're going to go like this and like this. Okay. So what that gives us is we're going to rewrite this formula now. We've got 3 times 123 is equal to 5 times x. Okay, now we want to solve for x. So to solve for x, we divide by 5. So if we divide by 5 here, we divide this side by 5 because we got to do the same thing to both sides of the equal sign. These 5's cancel, okay? And what we're left with is x equals 3 times 123 divided by 5. So that'll tell us how many bald men there are probably in this class at the surveying conference given that ratio. Okay, and I have not done that math. So let me do that math for you guys real quick. Sorry, I apologize. I should have had that math done. Okay. Okay, so based on my math, we can expect there to be, and I'm rounding up, 74 bald men in the class, right? So if we go back to our proportion, this number is going to be 74. Okay. Now it works the other way too. Okay, so let's look at another example. Let's say we go into another room at the conference. Okay, and in this room we don't get the total. We don't get to count the total number of men over 25. But as the men are leaving the room, we just count the bald guys. Okay, or guys in ball caps. We assume if they're wearing a ball cap, they're bald. Okay, so we get that in this class there are 34 bald guys. Okay, and we want to know what, based on our ratio of bald guys to men with hair, how many are there in the class total? We didn't count the total, we just counted the guys that were bald. Okay, so we do the same math, right? We use our proportion. So we've got 3 over 5 equals, now this time 34 goes on the top. 34 times the total number of guys in the class. We want to solve for x. Okay, so we rewrite this, we get 3x equals 5 times 34. Okay. We're going to divide this side by 3. Divide this side by 3. That cancels the 3's over here, and we get x equals 5 times 34 divided by 3. That'll give us our answer for the total number of guys in the class based on that ratio. Okay, so we get 5 times 34 divided by 3. That tells us that there should have been about 56 total men under the age of 25 in that class at the surveying conference. Okay, so that's how we can use proportions to solve problems. Now, those are silly examples. Let's use a more practical example from surveying. Okay, so let's say that we're building a road. Okay, it's a flat road, and then there's slopes. Okay, so it's an elevated road. Okay, this is dirt or gravel. Okay, and we know that these slopes are 2 to 1. That's a ratio, right? What that means is for every foot that we go over horizontally, 1 foot, we go down, for every 2 feet we go over horizontally, we go down 1 foot. That's a pretty common slope. Okay, it's a 2 to 1. 2 feet over, 1 feet down. This is called the run, that's called the rise. Okay, so 2 to 1. Okay, so let's write that as a ratio. 2, for every 2 feet we go over, we go 1 foot down. Okay, and I know that this horizontal distance here is 18 feet. Now I want to know what's the change in vertical. What's this change in vertical here? Okay, so let's write that as a ratio. I know my slope is 2 to 1. Okay, I know my total run, horizontal, is 18 feet, and I want to know how many feet do I drop. Now, we could do that math in our head, probably, and figure out that it's 9 feet, but let's do the algebra. Say we're going to cross multiply. We get 2x equals 1 times 18. Okay. Now we divide both sides by 2. I'm sorry, I didn't draw that, right? 2x. We divide both sides by 2. Okay, and we find that x equals 9. So we drop 9 feet if we run over 18. Okay, so that's how you can use proportions to answer questions, real-life questions. We do that a lot with slopes in land surveying. We're going to see that we use proportions a lot in trigonometry as well. Okay, so what is a ratio? A ratio is just a number that expresses a relationship, like the number of cups of sugar to every gallon of water in your sweet tea, or the number of bald men in a classroom to the number of men with hair. Could be any kind of relationship. What is a proportion? A proportion is 2 ratios that are equal to one another. And then we saw how we can use algebra, cross multiplication, and some basic algebra tools to solve problems with proportions. Pretty cool. We're going to do the same thing in trigonometry. Now you know all about ratios and proportions. Thank you for watching this Taught by a Surveyor video. We will catch you on the next episode.